the question is state whether the following statements are true or false. Justify your answer. The first one is every irrational number is a real number. So let's recall the definition of irrational number. So any number S can be an irrational number when it cannot be written in form of P by Q, where P and Q both are integers and Q is not equal to 0. While if we define the real number, so the real number is the combination of both rational and irrational number. So we can say yes, every irrational number is a real. The next one is every point on the number line is of the form square root of n, where n is a natural number. You see, let's consider a number line. Here on this number line, we can represent both positive numbers and negative numbers, right? And we know that we cannot get a negative number after taking a square root of any number. So let's say we are going to take a square root of 3. So now we will get the value of the square root of 3, that is the positive number, but we cannot get the number as negative, right? So therefore, we can conclude that not every point on the number line is of the form square root of m, where m is a natural number. So next one is every real number is an irrational number. So again we will take a definition of irrational number. So irrational number s, any number f will be an irrational number and it can be represented in the form of p by q, where p and q both are integers and q is not equal to the 0. So this is the definition of irrational number, while the real number is the combination of both rational number and irrational number. So we can say every irrational number is a real number. So therefore we can conclude that every real number is not an irrational number. The next one is, are the square roots of all positive integers is irrational? If not, give an example of the square root of a number that is a rational number. So let's take the square root of few integers. So let's say square root of 2. So what is this? Is this the rational or irrational? Yes, it is an irrational. Square root of 3. Yes, it is an irrational. Square root of 4. Square root of 4 will give you the 2. Whether it is a rational or rational, yes, it is a rational number. Similarly, square root of 5, 6, 7, 8, square root of 8, we will get 2 root 2 square root of 2. Square root of 9, again we will get 3. Again, this is a rational number. So we can conclude that square roots of all positive integers are not irrational. It may be rational or it may be irrational. It depends, right? So next one is show how square root of 5 can be represented in number. चलिए square root of 5 को number line पे represent करते हैं. First, let's draw a number line. So this is O A of unit length. Now draw a perpendicular to this number line from A of unit length. AB of unit length, that is perpendicular to it. By the Pythagoras theorem, we can calculate the length of OB, and that will be equals to the square root of 2. So let's draw a perpendicular line BC to the line OB of the unit line. So again, from the Pythagoras theorem, we will calculate the length of this line OC. So we will get the, from Pythagoras theorem, we will get the length of this line OC is equals to the OC equals to the square root of this OB square plus BC square. We will say this OB, the length of this OB is square root 2, so square root of a square is 2. So BC is of the unit length, so 1. So this OC is equal to the square root of 3. The length of this OC is square root of 3. Now again, we will draw a perpendicular to the line OC of the unit length. So now we will draw a perpendicular line CB to the line OC of the unit length. This is line OB. So again, with the help of Pythagoras theorem, we can calculate the length of this line OB. So using the Pythagoras theorem, we will get this OD is equals to the square root of this OD will be equal to the square root of BC square plus OC square. Again, OC is equal to the square root of 3 plus CD is equal to the length of 1. 1 का square 1, square root 2 का length, square root 2, square root 3 का square 3. So we will get the square root of 4, where the length of OD is equal to the square root of 4. So now we will get square root of 5. So again, we will draw a perpendicular to this line OD of the unit length. So now we will get a line DE that will be perpendicular to the line OD. The length of this line DE is 1. Again, now we will get this line OE, and the length of this line OE we will get the help of Pythagoras theorem. Then the length of OE is equal to the square root of this length ED square plus OD square. ED is the unit length, so 1 square plus OD. The length of OD is square root of 4 square. You can say it's 1 plus 4. So hence OE is equal to the square root of 1. This is the length of. So now we have to represent this square root of 5 on the number line. So now we will take a compass and the center of and take the radius as OE and will draw a arc. Center O and with center O and the radius OE, let's draw an arc. And it will intersect the number line at point F, and this point at F will represent the square root of 5, and this length OF will be equal to the square root